last class, a lot of folks talked about the difficulty with homework 27, where it referenced the Descartes' rule of signs and some things we didn't talk about. And so some folks ended up spending a lot of time and not finishing it. So I've decided to change things up a bit from what the original calendar is that we've been following the whole semester. So I have shuffled things around. We will talk about the new calendar. You can grab one right now. We'll talk about it in a few minutes. But what I will say for right now is that homework 27, which was originally due Monday, is now going to be due this coming Friday. So I've gone into my math lab and changed that date so you can get full credit, no 10% penalty as long as you finish this homework assignment by Friday. And there will be no other homework assignment due on Friday, so it's not like you have to do 2 assignments between now and then, okay? So what I want to do just in the first few minutes here is take a look at some of the homework for homework 27. Now, let's see if that's kind of small. All right, that's better. So I'm making a video of what we're doing right here. But I try to never make videos that include like proprietary stuff, like my math lab, for example. So I don't know if what I'm doing is illegal, but I can tell you that I'm going to take this video down off of YouTube on Monday, okay? So like between now and Monday is the time when you want to come back and check out my video because it's going to disappear, all right? So, so here's the first My Math Lab question. For me anyway, it says find all zeros of the polynomial function, and then I'm going to stop reading because it references the rational zero theorem, which we're not talking about, and Descartes' rule of signs, we're not talking about. It just gives us that, and it says find all the zeros. And so what we're going to do, now this problem might have different numbers than the one that you get when you log in. So the idea here hopefully will carry over. So what we need to do is graph this thing on GeoGebra. And so, so I've already typed in this formula and some others right here. So I just typed in down in the input bar f of x equals, and I copied all of that stuff. You guys know how to get powers, right, in GeoGebra? What do you type to get a power? Yeah, so it's x to the third power, right? It's just that caret to get powers, okay? All right, and so if I show you that graph, it looks like this. Now this question asked for all the zeros of this function. Now, how many zeros do you see? 3, because we know that zeros and x-intercepts go hand in hand. Now the idea here, if you could just read them all off, then this is a really super easy question. It looks to me like 5 and 1 and -2. But really, it's not supposed to be as easy as that. What we really want to do is find 1 0 just by inspection, and then we'll find the other 2 by doing some hardcore algebra, okay? And that's what I'm after here. So I'm just going to grab arbitrarily the 5, and then we'll figure out the other 2. Okay, so here it is. You can copy this if you want, but like I said, the video will be posted for a few days. The formula was x cubed. What was the rest of it here? Come on. Go ahead, Ina. Minus 4x squared plus 10. Okay, so we're going to use x equals 5. If you go ahead and do the calculation, 5 cubed minus 4 times 5 squared, if you just plug 5 in, you will see that you get 0, so 5 is legit. And what that means is that this guy right here, this original polynomial, has to have a factor of x minus 5 in it, right? We know that if you have a 0 at a number, then x minus that number must be a factor. It's the only way to get a 0 out when I plug 5 in for x. And so the goal of this problem is to figure out what's in the parentheses. And to figure out what's in the parentheses, well, let's see. I need to know how many times x minus 5 goes into this original polynomial. What operation do we do? There's long division, right? X minus 5 into that thing. And so we do the long division over here, x minus 5 into that original guy. I don't want to spend all of our class doing this homework assignment together, so we're just going to skip to the punchline here. But after you do the long division, you're going to get some stuff up there. By the way, what is the remainder going to be? Do we know? I want us to know. What is the remainder? X minus 5 was a factor. What will the remainder be if we have a perfect factor? It will be 0. There better not be any remainder. Okay, so the remainder is going to be 0, and you're not going to be surprised by that. But whatever you get above this division symbol goes right in there, right? And the thing that you get in that parentheses is going to be a quadratic, and you're going to factor that quadratic. and that's how you're going to get the other two zeros. Okay, that's the process. It is always the process. Let's take a look at the next one on the homework. So there's that guy, then there's this one right here, x to the fourth plus 62x squared, blah, blah, blah. So we're gonna look at a picture. We're gonna do exactly the same thing we did before. I'm actually not gonna write anything for this one, but you should be concerned about this guy. Even with the same process we just did, you should be concerned. Why? It's a higher degree, right? Let's suppose we look at a picture and we do the long division. We're still going to have an x cubed in the dot, dot, dot purple stuff that we just wrote up there, right? Power is just going to come down 1. And x cubed, I can't handle it. I can't handle x to the fourth. That's why we need a graph. And I can't handle x cubed because we just needed a graph. But there's one case where actually the graph is going to make it so that you can get it from x to the fourth directly to x squared, which is the only thing we can handle. And some of you maybe know where we're going with this. I'm going to hide that guy. I'm going to show you the graph for this one, which is this next question. It's there. So what is a zero of this guy? Is -1, which means what is a factor of the polynomial? X plus 1, x minus -1. But what's special about that graph at the x-intercept? It is a bounce. And so it isn't just x plus 1, it's x plus 1 squared, because we know bounces are even powers, right? So you're not going to be dividing by just plain old x plus 1, you're going to divide by x plus 1 squared. And so when you do that, you're going to get from a 4th degree down to a 2nd degree, which we can handle. I'm not sure what else is going on with this function. I mean, it might do crazy things up there. Looks like it's not so crazy. But it doesn't matter. All we care about is x-intercepts. Okay? All right, that is good. I'm going to get rid of that one. Next guy. Same idea. Again, it's an x to the fourth. I have a sneaking suspicion that one's going to have a double root. Let's see. Oh, actually, this guy has 4 roots that we can see here. Let's see. First one looks like -1. Second one looks like maybe -0.2. Are you confident it's -0.2? Oh, we're not going to pick that one, right? Next one looks like 2. Next one looks like 3. So really the tough one is that -0.2-ish. So what you're going to do is say, okay, if 3 is 0, then what's a factor? X minus 3. You do long division. And then 2 is a 0, so what's a factor? X minus 2. You're going to do long division, but from where? From what point in this process are you going to do that second long division? And it's once you get the previous answer from the first long division. You want to see? I think this one is tougher. Maybe we can just do a quick look at this guy. Can somebody write that down real quick? Because I need to write it on a blank page. Okay, I think we've got somebody that has it. All right. So coming back over here, we'll go here. All right. So f of x equals x to the 4. No. Okay. And I think that we saw that we had some zeros at 3 and also was it 2? 2 and -1. I think we just need 2 of those guys. Okay, so we're going to do our first division. First division is to say that this guy is really equal to x minus 3 times a bunch of stuff. So a big part of this problem is to fill in that blank right there, okay? So let's do long division. X minus 3 into the entire polynomial. 5x to the 4 minus 19, blah, blah, blah. I'm putting the blah, blah, blah because we're going to do the synthetic division just to save some time. Okay? But whether you like synthetic or not, this is an option. Right? This is like the traditional way to do it right here. But let's just do that division the synthetic way. So the synthetic way, you guys remember, what's the number that goes out here? It's 3. It's not -3. This is the first twist in synthetic, is that it's the 0, which is 3. Okay, and then we just put the coefficients, but we don't put any of the x's. So 5 and then -19, 1, 3, and 6. And don't forget, if one of those x terms was missing, you got to account for it. Like if there was no x squared, what would you put where we put this 1? You'd have to put a 0 there. It's really easy to miss that. It's not gonna have like a big, star around it that says, hey, look, there's no x squared. It's just not gonna be there. So you got to look for it. Okay, and then we'll do the process real quick. First thing is copying this guy straight down, 5 there. And now we get into this repetitive thing where we multiply and then add, multiply and then add. So 3 times 5, 15, add, -4, 3 times -4, -12, and then add, and then multiply, and then add, and then what happened? Yes. Well, 31x. That's good because here, let me finish and then we'll fix it. If we multiply here, we get -90, and we add and we get -84, and that is very problematic because what's the remainder supposed to be if it goes in evenly? 0. Nice way to catch. I mean, right? You saw me stop there because as soon as I saw we weren't getting 0, we made a mistake. Don't just proceed. Okay, so Aaron, you're saying it was a 31x plus 6. Okay, let's fix that there. Okay, so I think we just have to pick up right here. Okay, so we're multiplying. It's still -33. Now we add and get -2, and then we multiply and get -6, and then we say, phew, worked. And so what that means is that the thing that goes in the parentheses here is this guy, but just written with all the x's put back in there. I'm going to put a little line right here. That 0 is the remainder. This -2 is constant. X there, x squared there, x cubed there. That's the thing that goes in the parentheses. 5x cubed minus 4x squared minus 11x minus 2. Okay, so we have handled the the 3, and we got 2 other choices, right? And it doesn't matter which one we pick. So let's pick the 2. We could say that this guy is definitely equal to copy the x minus 3, but now because 2 is a 0, what's the next factor? X minus 2 is definitely there times something. I don't know what the something is. So the goal I'll highlight here. So all of this is supposed to equal all of that, and we just got to fill in the right thing. Okay, and so how are we going to break this yellow thing up? By getting rid of this x minus 2. Another division, right? It's x minus 2 into the new thing. So I'm just going to write this, and then we're going to stop with this problem. But x minus 2 into the new purple guy. I'm not going to do any more. But whatever you get here, where does it go? Right in this empty parentheses here. And that guy will be quadratic, and quadratic is easy. And it's wild to me that like quadratic is easy and cubic is impossible without graphing and guessing, right? Like it's just this, like it goes from being like easy to impossible with nothing in between. And that's why we need the technology to help us bridge that gap. Okay, that is tough, but the process hopefully makes sense to us. It's a little bit of practice, this process, you start to see it's just the same steps over and over again. Any questions on that? Okay, and I think there was just one other one that I wanted us to look at here. This next guy looks almost the same. Here we actually don't even need to use GeoGebra because it's got a partial picture here. How many zeros do you see in this picture? There's 1, it's right there. Now don't guess. I mean, I'm guessing that's the y-axis and that's -1, -2, -3, but don't guess because the hash marks might mean something different, right? So you really do need to look. Where is it? Where is it? I thought there was, oh, it's right at the bottom there. Scroll down, there it is. Okay, this is something that you're supposed to understand what it means relative to that picture. What is the smallest x value? Is the -5. What's the biggest x value? Is a 0. And what does this 1 mean? that the hash marks are 1 apart. So my guess was okay. It was 0 and -1 and -2 and -3. And so that's the number we're going to use, -3. The y's don't really matter much, but anyway, -35 at the bottom and 30 at the top by 5s. Okay. So same process, but even easier because they give you the picture. As long as you can read the window dimensions, you're good to go. This guy looks the same to me. This is another thing that's similar. Okay, let's take a quick look at this guy. X cubed minus 11x plus 20. All right, so this is the last one that I graphed right here. X cubed minus 11x plus 20. It's that one. So it's just saying use some grapher and then pick the right one. It's a multiple choice. So which one? Here it is again. So we're just trying to pick which one. It's that guy. And so then it says, okay, hey, check my answer. Yeah. And then it says it has how many real zeros. I think we're just a little too big here. Okay, how many real zeros do we see? Just the one, so we're gonna put 1 there. Check the answer. Yeah, all right, and then imaginary zeros. Now this part is easy as long as you know what they're after. The degree here is 3. How many zeros does every degree 3 polynomial have? It has 3, right? Degree is the same as the power. And we've already established that exactly one of those 3 zeros is a real number. So how many are imaginary that we do not see in the graph is the other 2, right? And so this is really just asking, do you understand whatever you don't see as reals, the leftover has to be imaginary. There's no other choice. Excellent. Hey, my homework average just went way up because I had a 0 for the whole semester until right now. So I'm stoked. It's great. All right, any questions on that? Okay, so just to reiterate, this homework was due Monday. I am now pushing it back to this coming Friday, and that is the only thing due for you on Friday coming up, okay? So give it another shot. Hopefully it will go smoothly this time. 20.